Hey everyone. So if you've ever plugged a computer into a router, you've used Ethernet. But have you ever looked at the specs and seen something like 1000 base T and just thought, what on earth is that? Well, today we're going to crack that code. And just so you know, if you want to go even deeper, all the source material is linked down in the description. All right, let's jump in.
Yeah, you've definitely seen these, right? Stuff like 1000 base T or 10G base T. They're all over your router, your network card, the tech specs. And they look like complete gibberish, just a random bunch of letters and numbers. But I promise, it's not random at all. There's a really simple logic to it, and we're going to figure it out together.
Yep, that's what we're here to do. It's like we've got a secret decoder ring for networking. By the time we're done here, you'll be able to look at any of these standards and know exactly what they mean. And trust me, it is way simpler than you'd think.
Okay, so first things first, let's set the stage a little. Before we can decode the names, we gotta have a quick chat about what Ethernet is and, why it matters so much.
At its core, Ethernet is basically the rule book for that cable you're always plugging in. The one with the little plastic clip? It's the standard that lets everything from your laptop to your gaming console connect to a network. It's the magic behind that super stable, super fast wired connection we all love.
So you might be thinking, if Ethernet is this one big thing, why are there so many different names for it? And that is a great question. It all comes down to why we desperately need some order in the networking universe.
I mean, just imagine the chaos if every company just made up their own rules. It would be a total nightmare. You'd have cables that don't fit into ports, devices with speeds that don't match, and equipment that just flat out refuses to talk to each other. So standards are here to make sure that a gadget made in one country can plug into a network on the other side of the planet and it just works. No drama.
And the group we have to thank for this, the hero of our story really, is the IEEE. That stands for the Institute of Electrical and Electronics Engineers. It's their 802.3 committee, specifically, that sits down and creates these universal rulebooks that keep our entire wired world from falling apart.
Okay, background check is complete. Now it's time for the main event. Let's get that decoder ring out and start breaking down this secret formula that's been hiding in plain sight all along.
So, to do this, we're going to use a super common standard as our key, and that is 1000 base T. Seriously, if you have a modern wired network, odds are you are using this exact standard right now. And here's the cool part. Once you understand this one, you'll be able to unlock all the others.
As it turns out, pretty much every Ethernet standard follows the same simple three-part formula. It's just a number, the word base, and then a letter or two at the end. The number tells you the speed, base tells you about the signal, and the letter, that tells you what kind of cable you're using. That's it. So let's break each part down, one by one.
All right, let's start with part one, the number at the very beginning. This is probably the easiest piece of the whole puzzle.
So in our example, 10,000 base T, we've got that big 1000 right at the front. And yeah, you guessed it, that is all about speed. That 1000 literally just means 1000 megabits per second, or as you and I probably call it, gigabit Ethernet. See how simple that is? So when you see a standard that starts with 10G, you immediately know, yep, 10 gigabits per second. It's really that easy.
Okay, speed is down, check. Now, let's look at the middle part, that word base. It's in almost all of them. So, what's that all about?
Well, base is just shorthand for baseband signaling. Now, the easiest way to think about this is like baseband is a private one-lane road that's used only for your network data. It's totally different from something like broadband, which is more like a huge multi-lane highway with all sorts of different traffic on it. For Ethernet, it's all about that single, dedicated, private lane.
All right, on to the final piece of the puzzle. Part 3, the letter or letters at the very end. This part tells us something physical, something you can actually touch. That T in our example, 1000 base T, stands for twisted pair, as in the standard copper Ethernet cable that we all know and love. So let's put it all together. 1000, that's 1000 megabits per second. Base, that's baseband signaling. And T is for twisted pair cable. See, we've done it. The code is cracked.
So now that we have the key, let's put our newfound skills to the test, right? Let's see if we can decode a couple of other common ones just as easily. Check this out. What about 10G base T? Well, 10 is 10 gigabits per second. Base is baseband. And T is twisted pair. Boom, done. Okay, how about a trickier one, like 1000 base SX? The 1000 is easy, that's still 1 gigabit. But the SX at the end?
That tells us we're not using copper anymore. Now we're talking about a totally different kind of cable, in this case, fiber optic.
And those letters are where you get a lot of the extra detail. T is our trusty twisted pair. You'll often see an F for fiber optic. And then you get two-letter combos, like SX, which gets even more specific. That one tells us it's not just fiber, but fiber that uses a short wavelength of light. Pretty neat, huh?
Okay, now before you run off and add Ethernet decoder to your resume, there is one last really important thing we need to talk about. Think of it as a little warning label that comes straight from the folks who make these standards.
So here's the deal. Our little decoder ring trick is awesome for getting a quick idea of what's what. But the IEEE themselves are very clear about this. The name is just a name. It's a handy label, for sure, but it is not the whole story. It doesn't have all the nitty-gritty technical details.
And they actually say that if you're interested in the details, you need to read the entire standard and not just look at the name. So for the really critical stuff, like exact cable lengths, performance specs, all that important jazz, you've got to go to the official document. Think of the name as the key, but the full document, that's the treasure map.
But hey, it's still a super powerful key to have, right? You can now look at the world of wired networking, and those once confusing labels will actually mean something to you. You've turned that gibberish into real, useful information. So the next time you see one of those standards, you'll know exactly what you're looking at. Thanks so much for joining me.